Welcome to week 9, where we're going to talk about right and left heart hemodynamics and fractional flow reserve. This actually is the third week that we have spent on hemodynamics and calculations. And so this week we're going to focus on these two things. I do want to mention that chapter 12 is devoted to hemodynamics, so I recommend you read it and reread it and reread it. What we're going to talk about right now starts on page 169. What you need to know is that there are three waveforms that you need to be able to recognize. They are the atrial waveform, the ventricular waveform, and the arterial waveform. So we're going to start with the atrial waveform, and remember the atrial waveform, that could be the right or left atrium. This example just happens to be the right atrium. And in order to tell the difference between the right and left atrium, you have to have a scale. That's the only way you can tell the difference. Other than that, they look the same. But the atrial waveform is characterized by looking double humped and squiggly, is the best way I can describe it. The atrial waveform actually has deflections in it, like it's broken down into parts. To be honest, when I took my test, I didn't know all of the different parts, so I don't think it's necessary that you know all of the little parts, but I will talk about them briefly. So double humped, meaning there's two times where the atrial pressure is higher, and it coincides with the EKG. The first is the P wave is atrial contraction, and so as you can see, along with the P wave is this upward deflection in pressure, so that makes sense. The other time is during the T wave, and that's when the heart is at rest, and those valves, I'm sorry, not the valves, but the heart is at rest, and so those atria are filling when the heart is at rest. So double humped, meaning the two times where the atria are increasing in pressure. So when the atria contract, that goes along with the P wave, and when the entire heart is at rest, which goes along with the T wave. So double humped and squiggly. The next waveform that you need to be able to recognize is the ventricular. So again, when we're talking ventricular, that could be either the right or left ventricle. The ventricular waveform is tall, and it goes clear down to 0, because if you remember your pressures, the systole, like for the right, for example, is a 25, but then the diastole is 0. Same for the left, the systole is like 120, but the diastole is 0. So, and then that is demonstrated in the waveform as well. So it's a tall waveform, the lower part goes clear to 0 to the bottom of the scale. The important part to know about this waveform is the peak of this waveform is at the height of systole. So again, your R wave is going to be a little bit past your R wave. So here's your R wave is going to be your peak systole. The other important part of the waveform is the EDP, and that is just before ventricular contraction, just before the upslope. So here it's showing you the EDP is right here, just before the big upslope. That is your EDP, your end diastolic pressure. And then the third waveform that you need to know is arterial. So mainly your pulmonary artery and your aorta, any artery really, but those are the two main ones that you have to be able to recognize. The pulmonary artery, remember, is like 25/10, where the aorta is your normal arterial pressure, like 120/80. But the arterial waveform is triangular in shape, and it has a dichrotic notch on the downslope. And so, which is just a little bump this arrow is pointing to, and what that signifies is when the valve closes. So if we're talking about the pulmonary artery, it's when the pulmonary valve closes. When we're talking about the aorta, it's when the aortic valve closes. So that is your three waveforms in brief.